You are about to become slightly smarter than you were not very long ago. Okay. First of all, let's establish what volume is. Volume is different than area. Area is how many squares something has, square feet, square inches, square whatever. Volume is okay, right, and we measure that in measured in cubes. And again, people, you must understand it's all relative to the unit of measurement that you're using. For example, a cubic centimeter is not very big. It's something that would look something like this, a centimeter cubed. A cubic inch gets a little bigger because it's an inch on all sides. A cubic foot, 1 foot by 1 foot by 1 foot, is bigger still. A cubic mile, you're starting to talk a pretty big distance of space. A cubic yard, by the way, those of your parents in the construction business or whatever. Concrete, when it gets delivered to your house, if you're pouring a sidewalk or a driveway, comes in cubic yards, which is, if you think about it, it's a pretty good chunk. It'd be about this tall, this wide, that wide. It's bigger than you would think, but it's large there. And volume, here's what the deal is. You have to get it out of your head, and I heard Josh say it once or twice or whatever. If you're talking about just a simple, box, which we call a rectangular prism, okay, you are allowed to use the formula that volume equals length times width times height. That works for that. If it's a rectangular prism, feel free to use this formula. Okay, it's just a simple little thing you've done since whatever, 5th grade or whatever you were. If it's just a rectangular prism like that, 2 inches by 3 inches by 4 inches, sure, volume equals 2 times 3 times 4, and volume equals 24 inches, and that's all well and good. Okay? Make sure you note that. If it is this, a simple prism. But today we're moving ahead because you're smarter than simple prisms. We're going to a more complex sort of shape here. And this is what you must get here. And here's going to take a little sketching for you. If you have this shape right here, or any shape, okay? Write down this because you need to write this formula down. For every other prism, by the way, this is not a rectangular prism, it's some sort of a hexagonal prism or whatever it is. You must use this formula. Volume equals the area of the base times the height. And rather than writing that out in big, long words, we do it like this. Volume equals capital B, that's the area of the base, times little h, which stands for height. Just that simple, kids. We can move on now. No, we can't. in order to be able to do this, ladies and gentlemen, you have to know what the base is in order to figure out what the area of it is. Now, does anybody know what the base is of this shape? I suppose I should write down some dimensions. Suffering from dementia, if I would be so kind of 10, 20, 15, 12. 10, 20, 15, 12, obviously not drawing a scale on that, and 12. 12 and 12. 12 and 12. Okay, here's the deal. And I probably need to get out another little shape here to kind of give you the gist here. Do we have another shape? I know I got some shapes here. Don't worry, kids. And here's one. This would be one. Okay, let's start with this one first here. If I've got this shape right here, and I asked you what the base is, and I set it down like this, what would be the base? Caroline. The bottom. That is incorrect and a common fallacy. Most people think that, because usually we do set things on their bases, but in this case, that bottom is not the base. Ava Wyrick.
The side that's facing you.
The side that is facing you. Another common misconception in math. The base does not change no matter how I set it, no matter how I look at it. Just like if I'd ask you what the base of that shape I have drawn there is. What would it be? I'm a Kunacek. I, by the way, have spent many hours deliberating this, and I've come up with my own theory on it. Ashley?
The area of not the whole shape, like if you flatten it out, like just area of the shape. That's
So what is the, tell me what that would be on this.
it would be
I flattened it out, like stepped on it, and it just splattered?
no.
Of a net, if you cut it apart and made it, folded it out?
It could be anything.
Alright, yes. Kendall.
It's the triangle.
It is the triangle.
Yes!
How do you know that?
Because it's the main shape and then just stretches it out and makes it 3D.
I should use the stretch it out kind of idea. Well, I like my theory better. The base, children, write this down because you will forever remember this. I like to call finding the base my loaf of bread theory. Okay, which means simply this. If you had a loaf of bread in that shape, how would you slice it so you always get the same shape? How would you slice it to always get the same shape? Okay? Which means, let's go back to this thing here. Okay? And obviously, logically speaking, if I'm giving you this thing and you're putting it in the toaster, okay, alright, you would shave it like this, right? And you'd always get these triangular pieces. Because if you were to take your loaf of bread and stand it like this and slice it parallel to this rectangle, what's going to happen with each piece of bread? Well, the first one's going to be this big, but as you keep getting close to this, it's going to keep getting to be a smaller rectangle, Until you get to the end right here, you're going to get some sort of a pointy little sliver of a piece there. Okay? Same thing with this shape. If you had a loaf of bread, and this kind of looks goofy because I got that thing, in that shape right there, and you needed to slice it so that everybody got an identical looking piece of bread, how would you slice it? Would you slice it like this? You'd get squares here, but once you got to this point, you'd start getting long rectangles. No, you wouldn't slice it like that. Would you slice it over here? No, because same thing, you keep getting those squares that you got here. You would slice it how, Gabe?
From the side.
Right, you would keep slicing it like this, because no matter where you slice it, going up like this, you are always going to get this shape. You'd always get that L piece of bread. And that is what the base of this thing is. The base of this thing is that L shape. Okay? And then, we've established what the base is we need to find the area of. But now we've got this other thing which is called the height. Okay? What is the height? And everybody thinks, well, that's how tall it is. Well, here's the deal. Okay, if I were setting this same triangle on its side, the height of this shape is not this distance from here to here. Okay, the height has to be, write this down, the height has to be if you set the shape, oh boy, if you set the shape on its base, how tall is it? Or another way to say it is the base and the height, wow, the base and the height have to be perpendicular. Have to be perpendicular. Now in this case that I gave you, they are. This shape is setting on its base, and it's setting on its bottom, like I think Christine said. Okay? But if I would flip it over and set it on its side, it doesn't change what the base is. The base is always going to be this L shape. The height is always going to be 10, because 10 is perpendicular to the base. That's how high that thing is there. Let's see if I can find something here. Open your book to page 290. I want to find it. Don't worry, I'm going to find something. And maybe I can't find an example. Maybe I'm out of luck. And I don't want to make one. They're too hard to draw. Maybe I can. If you have a pentagonal prism like that, and let's say this is, each side is 5 inches here, and this thing is 20 inches deep like that. If I asked you what the shape of the base is, you would tell me, Sam Poppin, on the loaf of bread theory, it is a...
This shape is an hexagon.
This shape is a pentagon.
Pentagon.
Oh.
So the base is a pentagon. It's this shape right here, because if you slice it like a loaf of bread, which it kind of looks like, if I asked you what the height of that shape would be, you would say it is...
Me?
Sure.
5 inches.
It is not 5. Again, remember, if you think about taking this shape and setting it on its base, it's how tall it is. It is not 10 inches.
It's 20.
20 inches. Or like I said, it's the dimension that is perpendicular to the base. Okay, perpendicular forms a right angle. That's what it would be. Okay, the height, and it gets confusing because if you have a shape like this shape really has 2 different heights to it. You've got the height of the shape, which would be this, and you have the height of the base, which would be, if you finding the area of the triangle, you'd find the height of the triangle. There's 2 different heights, and you have to know which one you're talking about. Height of the shape, height of the base would be this. So it gets more than a little confusing, it gets a lot confusing. Now, take a look at page 290. And this is why back in 6th grade, you said how come they always get smaller assignments than we do. Look at problem letter E. It says, what is the volume of this block T? Well, obviously, the first thing you're going to do, Bailey Lankin, is do your best to sketch that thing out. And go ahead and do that on your paper somewhere, notes or wherever you are. It's a block T, so it looks a little like this. Remember we talked about what isometric drawing or whatever that was. You should be getting somewhat decent at sketching some of these things. And obviously putting those dimensions on there, like 2, 8, 3, 2, 8, 3, 2, 2, 8. I am going to walk you through this so that it's very clear as to what you need to show when you get to these problems. They will not be quick problems. So for those of you who spend your time speeding along, you'll be at a certain disadvantage there. Once you have it sketched here, what do you suppose, Gabby, is going to be the next step? What do you suppose would be the next step? This is where you got to train yourself. You have to be disciplined because you don't think about this, but really it's logical. Ashley?
Find the base.
What would be the next step? So that's one of them. Mackenzie? Thank you very much. You want to write the formula. Volume equals, and you can just put, I would just usually put AOB, area of the base, times the height. And I can tell you, people, the reason why this helps is because what will happen is, if you jump right into finding the area of the base, and the base is kind of a complex figure, shape, where you're going to have to do some calculating, usually what happens is you find the area of the base, and you think you've done the problem because you got so wrapped up into it, you forget about the second part, which is you have to multiply it by the height. Okay? In this case, you know what I would do? I would fill in the blank for the height right away because I should be able to tell me, you should be able to tell me what the height is. The height of this shape, Kunacek, is 2. Why? Because if it's setting on its base, which is the letter T, it's too high. So right away I put my 2 there, so I think to myself, I am not going to forget to double this when I get done finding the area of the base. Okay, and then finding the area of the base, you've already got it sketched there. Sometimes the book will rewrite the area of the base out. They'll give you the base, they'll make this letter T, and they'll give you all the dimensions you need to know, and you can just do this, this is 2, 8, 2, 3, 8. Okay, how do you find the area of that? You're going to split it into a couple pieces. Those pieces both will be rectangles. What's the area of this rectangle right here? 16.
16.
What's the area of this rectangle right here?
16.
It is not 16. Yes, it is. Sorry about that, Kelly. It is 16. So the area of the whole thing is 32. And then that's the number that gets put in right here. And volume equals 64, whatever it was, inches squared, inches cubed, or whatever.
Centimeters.
Was it centimeters in the book?
Yeah.
Okay, but you really, again, draw the shape, write the formula down, organize yourself, you know, drop in here what you already know so you don't forget to do it at the end, figure it out, and then you're pretty much good to go. They get to be a lot more complex than that. Ashley?
The first shape that you had, the shape that you did something for, how would you find that one?
This one? Well, they'd have to tell you, they'd have to give you more information. You couldn't find the area of that. Well, maybe you could. Could you? Could we split this into a couple triangles here? Do we know?
Oh my gosh.
Do we know what the area of this would be? Do we know what this height would be? Probably not.
Isn't it five? Oh, I never mind.
Maybe not. I don't know, no, they'd have to give you the height of one of those triangles and then you can figure it out, but after that, no. I didn't,